Happy Christmas everyone. So today we are going to start this 2389 lead code question, the longest subsequence with a limited sum, right? So this question is very easy, right? So it's saying that you are given an integer array num of n and an integer array, right? So query m. Okay, so two things are given as you can see, right? Num of I and num of what sorry, queries, right? Now what we have to do, we have to return an answer of length array, right? And the answer of I should be the maximum size of the subsequence that you can take from the num of I, right? And the sum of element is less than equal to query of I. So a subsequence is what? A subsequence is an array that can be derived from another array by deleting or some value escaping, okay, without changing the order of the remaining element, right? So as you can see here, give me 1 minute, I will increase yeah. So as you can just see that there is another example, right? Example is saying that we have nums, right? So in the nums what we will do, we will have a query, right? Nums and query, we have two array given and we have to find the output. How? See, if we have to do sum for sum, right, of 3 to get the 3 from array nums. Let me repeat again. If I have to find 2 element or 3 element or whatever the element, that will be, that we will do sum and then that will be 3. Like you can see, I have taken a subsequence 2 1 from this array nums, right? 2 1, and it is the sum of 2 and 1 is 3, right, equal to 3. So we are doing this way. So now you can say that 2 at 0, right? 2 at answer of 0, what we have? We have 2, correct? Next, if we'll calculate, right, we have to get 10, right? So we can take 4 5 and 1, correct? So which is less than or equal to 10, correct? So we can say that answer of 1 is what? 3, okay, because it is what? The maximum. It is proven that the 3 is the maximum size of subsequence. So previously the size was 2, now the size is 3, correct? Similarly, if we check for 21, we have to get all the element, right? And it is, the size is nothing but what? 4, correct? So we can do like this only, okay? So always make sure that you have given two things, the num of I, nums, right, and query we have given. So for all the element of the queries, right, query, what we can do, we'll find the elements from the nums and we will make a temp array, you can say that, and the size of the temp array is nothing but our answer of I, okay? So this problem, we can say, we have given nums, right, and query. So our task is to find each query in queries, and the maximum size of the subsequence we can pick, so that the query, so the sum of its query element does not exceed the query, right? So we'll start with our first approach, that is sort and count, right? So this, for this approach, right, query we want the maximize the size of the subsequence, and which means we want to collect as many as number as possible before their sum exceeds the limit query. Or another key observation is that the target we look for does not depend on the order of the subsequence, and it becomes a set of element necessarily. So in this case we are allowed to sort since it is order independent, right? So we can do sorting and other thing, right? So what we can do, so we should collect numbers from the lowest to the highest, right? So we have to do sorting of numbers, and which is therefore necessary for it, correct? And it, and to traverse over the numbers, right, we have to do sorting. So we will collect all the numbers from the lowest to highest as we require, right? So what we can do, let's see here. I am saying if number we have given 4521, right? What number we have given? Nums we have given 4, 5, right? We have given 4 5 2 1 like this, correct? We have given, or we can take another number also. We can take 4 at random number. We can take 4 5 1 and 6, right? We can take one more big number 13, this. So if we will sort this, right? If we will sort this, what will happen? We will have 1 2 4 5 and 6 13, right? Like this, 6 13, right? And this is our sorted nums, right? So as you can see, if we have to do sum, right, and there is some query value, let's see, we have some query value, and query value is what? We can take 3 10 21 we have given, right? And one more take will take 2, and this is what we have queries, this query, okay? We can do that, right? This query. So if I have to make these 3 from this sorted number, right? What we will do? We'll collect 1 and 2 from the sorted number, right? So to find how many number we can collect from the given, right, query, for each query in the queries, right, we have to select some numbers from sorted numbers, right? It means you can see that we can do easily, right? So rather than 100, right, if this is 10, right, so what we can do, we can collect 2 4, right, or you can say 1 2 4, how many? 7, right? So we have to check another value, right? Is that possible? Is that possible? So what we can do, we will see 1 2 is 3, 4 is what we have. So we have to actually see this value one by one, and we have to make the sum, right? So either we have to escape some number and then we will move to another number, right? So sorting is better than I think collecting from this subsequence, right? So it will reset your uh, nums, you can say, from in sorting order, and it will easy to move from left to right. I think you gotcha. Okay, so algorithm is what? We have to sort the number, and then we will initialize the empty array, and for each query we traverse the sorted number and collect the number from the lowest to highest, right? And we have to record the maximum number of element we can collect, that is count, and before their sum exceed query we have to add count on the answer. Count is nothing but the size of the array, and we have to return the answer when the iteration stops. We cannot yeah, we can say that, yeah. And finally we will return the answer, right? So let's start, right? So first of all, what I told first is we have to sort the number, right? So how we will sort the number? So there is a function, there is a way, or we can say function. Let me make it bigger. Okay, so first of all, what we can do, give me 1 minute. We will do arrays dot sort, and we will pass the nums, correct? First of all, we will do this, and our array is now sorted. Now if we will talk about the size, right, n or m we have to take, right? We will take n is what? Nums dot what? This function size, right? Length we can take length, and another is int m then we will take queries dot length. Correct. Two things we will take. We have to sort the array, right? Now we have to define an answer so that we will return the answer. Answer is array. We will take answer equal to ans answer, and then we will take new int, and we will take m. Answer should be size of m. Correct. So for each query we will collect numbers from lowest to highest for each query. So if there sum exceeds the limit query, we will move to the next query, right? So what we have to do, we have to move from left to right. How we will do that? We have to make a for loop, correct? Because for each query we have to collect some numbers, right? So what we have to do, we have to take int I equal to what, 0, and then we'll take I should be less than m, and then plus I. Correct. Then what we will do, we will make int count equal to 0, and then we will do int query equal to queries, correct, of I. Now we have count 0, we have initialize count from 0, and then we will take one query from queries, right? Now we will traverse another one, that is another we can say array, and we'll take one by one number from what, nums. You gotcha? Next what we will do that here, if query let me do, I have already said, we'll take query, right? And we'll see that if query is greater than or equal to, if this is greater than or equal to, what we will do, we'll check with num, right? If it's greater than equal to, what we can do, we will do count plus plus, right? Count, we will do count plus plus, we have to increase, right? Then we will do query, and then we will do num, right? We have to reduce the query also, right, one by one. And if that is not the case, what we should do, we have to take an else condition, else break. We can do break here. If that is not the case, we don't have to do anything. And after this loop, right, we have our count. We have our count, right? So this count is nothing but what, answer of I, this. And once this loop is done, what we have to do, we have to return all the answers, correct? Let me check. Yeah. So thank you guys for watching this video. And if we talk about the complexity is what, time complexity. So time complexity is, we have moved one to another array, right? One array, inside there is another array, right? So we can say if O of, we have traversed m, and for all m we have traversed what, we have traversed another array, So we can take m into n will take, but or a plus 1. After that we have moved to n log n, right? This one, n log n, correct? How? Because see, first of all, why I am taking, first we have sort the num, right? First we have sort the num, which will take our what? O of n, O of n time, let's see. And then for each query we need to iterate over sorted number, right? For each query. So to find the longest subsequence, right, we have to do this. We have iterated for each query all the nums again and again, right? And which will take what? O of n, right? Which will take O of n. And sorting will take what? N log n. And sorting will take that. And for each query, what? We iterate over nums, right? Is what we have taken? We have taken O of m into n, correct? So this time. So if we'll calculate total, say m into n plus O n log n, we can say that, right? But for the space, we are not taking any extra space. Rather than we have created what? Some extra space we have used, like we have sorted the nums, right, in the first place. And this space complexity of the sorting algorithm depends on programming language, right? So in the Java, arrays.sort is the implemented using a variant of quick sort algorithm, right? And quick sort, quick sort will take to sort array dot sort, right? We used to do, and this will take what? O log what? N, correct? Or O, this one we can say O log n. Either O log n or O log n, depends on the language, right, we are using. So let's see the next approach. We will see the next approach in the other part of this video. So please ping me for the understanding of another approach, that is prefix sum, and in which we will use binary search. Thank you guys for having me here. Please like, comment and share if you really like this video.